We're on chapter 12, section 3, which is called Inscribed Angles. And our learning objective is a long one. I will find the measures of an inscribed angle and the measure of an angle formed by a tangent and a chord. Yay. All right, so vocabulary words for this section. There are 2. Doggone, if the section's called Inscribed Angles, we should know what an inscribed angle is. Its vertex is on the circle, so you see it right here. Here's the vertex right on C. And the sides are chords of the circle. So chord BC and chord AC make up the sides of your angle, and the vertex is on. And I just wrote a little arrow here to show that we're talking about C. So that's an inscribed angle. Its vertex is on the circle, and the sides are chords of the circle. And we did the chord was our definition. An intercepted arc, so if we're using the same picture, which please, let's use the same picture and save ourselves some effort. An intercepted arc is this guy here, he's AB. Endpoints are on the side of an inscribed angle. So an intercepted arc is the resulting arc from an inscribed angle. So inscribed angles theorem is the measure of angle B is, we need a picture for this. So the measure of angle B is 1/2 the measure of arc AC. So I'm going to put a little picture right by it because I have drawn this arrow, and boy, his letters don't match up. So if I have this point is B right here where my vertex is at B, point AC are on the circle. So the measure of angle B right here is 1/2 the arc length measure. All right, so here is a couple of different ways that you guys are going to see this. If I have this circle here, and if I have A is here, B is kind of next to it, I have A and B both share the same arc. Boom, boom. Then angles A and angles B are the same. They're going to be congruent. So if your 2 inscribed angles share the same arc, if you look, they're not at the same place, but they share the same arc, then those angles are congruent. Okay. So another property that goes along with this is if I have a diameter, then your inscribed angle is going to be 90 degrees because what's the arc length of half of a circle? What's the arc measure?
180.
180, because the whole circle is 360. What's half of 180? 90. So if you have an inscribed angle that is a diameter, then the inscribed angle is 90 and the arc length is, or the arc measure is 180. All right. Last property that comes from measure of angle B is 1/2 the arc is that if I have an inscribed quadrilateral A, B, C, D, then opposite angles are supplementary. So angle A and angle C add up to be 180, and angle D and angle B add up to be 180. Last theorem, 12-12, is regardless the situation here, whether C is intersecting a line tangent or regardless the scenario, obtuse or acute angle, the measure of angle C is going to be equal to 1/2 the arc length of BDC. So you can go either way with this. You can go, I know the measure of the arc length BDC, so I can find angle C. Or I know the measure of angle C, so I can multiply it by 2 to get the arc length. Either direction is, you can use this formula for.